Today we're going to be looking at an example where we calculate the covariance and correlation between two assets. In this case, it's going to be two stocks here, and we're given stock 1 and stock 2, and we're also given their return estimates based on different states of the economy. So as we can see, a recession has a 30% probability of occurring, and stock 1 is going to return negative 20% or negative 0.2 in a recession state, and stock 2 is going to return negative 10% or negative 0.1 in the recession state of the economy, which again has a 30% chance of occurring. And the normal state of the economy, which has a 20% probability of occurring, stock 1 is going to return 10%, stock 2 is going to return 20%. And in the expansion state, which according to analysts, let's say has a 50% chance of occurring, stock 1 is going to give us a 50% return, and stock 2 is going to give us a 30% return. So now from this information, we're going to calculate covariance and correlation. So the first thing we're going to do is calculate each of the stock's expected returns. So let's do stock 1 first. So we're going to be looking at this information here. And it's basically just a weighted average. It's fairly simple how we calculate this. We're going to just take the 30% probability of a recession occurring. So that's this 0.3 right here. And we're going to multiply it by the return of stock 1 in the recessionary state. So that is this negative 0.2 right here. So we multiply those two together, and then we're going to add that to we're going to add it right here, and then we're going to add that to the probability of the normal state occurring, so 0.2, and we're going to multiply that by the return of stock 1 in the normal state, which is 10% or 0.1. Then we're going to add that again to the 50% probability of the economy expanding, that 0.5 right there, and we're going to multiply it by the return of stock 1 in the normal or in the expansion state. And then when we do that, we get an expected return of stock 1 of 0.21 or 21%. And then we follow the same steps for stock 2, and we come up with an expected return of 0.16 or 16%. So now that we have the expected returns, we're going to move on to the next step, which is calculating the variances for stock 1 and stock 2. We're going to use that to denote the variance of stock 1. And so how we calculate this is we're going to take this 30% probability of a recession state occurring, so that's that 0.3 right there, and we're going to multiply it by this return of stock 1 in the recessionary state, which is negative 0.2. which is that right there, and we're going to minus from that in bracket, that's why we put it in brackets, the expected return of stock 1, which is 0.21, and then we're going to square it. And then we're going to add it to the probability of a normal state occurring, which is 0.2. Again, we're going to take the return of stock 1, and we're going to minus or subtract the expected return of stock 1 from that return in the normal state. So 0.1 minus 0.21, and then again, we're going to square that, and then we're going to add that to the probability of an expansion state occurring. Then we're going to multiply that by the 0.5 return minus the expected return of 0.21, and again, we're going to square that. And when you solve for that, you get 0.0949 as the variance for stock 1. Now we can calculate the variance of stock 2, so we're going to take the 30% probability of a recession occurring, and we're going to multiply that by the return of stock 2 in the recessionary state minus the expected return of stock 2, and we're going to square that. Then we're going to add it to, again, the 20% probability of the normal state occurring, and we're going to multiply that by the return of stock 2 in the normal state, which is 0.2, minus, again, the same 0.16, which is the expected return of stock 2, and again, remember to square it. And finally, for the expansion state, we're going to use 0.5 to represent the 50% probability of an expansion occurring, and we're going to multiply that by the 0.3, which is the return of stock 2 in the expansion state, minus the expected return of stock 2, which is the 0.16, and we square that, and you get a variance when you calculate that out as of 0.0304. Now that we have the variance of stock 1 and 2, we may as well calculate the standard deviation next, because we will need that for the correlation calculation coming up. Remember, the standard deviation is just the square root of the variance. So to calculate the standard deviation for stock 1, we can just take the square root of this is 0.0949, and you get, when you do that, you get 0.308. That is rounded to 3 decimal places, and we're going to do it for stock 2 as well, just to keep things simple. And we can take the square root of the variance of stock 2, and when you do that, you get a standard deviation of stock 2 of 0.174. Now we can calculate the covariance between stocks 1 and 2. So how we're going to do that is we're going to take the 30% probability of a recession state occurring. We're going to multiply it by a negative 0.2 minus 0.21 and negative 0.1 minus 0.16. So where did we get these numbers from? You notice that we did them in the variance calculations for both stocks 1 and 2 respectively. So the only difference is we added this square. We don't have to square it in the covariance calculation. So the 0.3 comes from the 30% probability of a recession occurring. And then this negative 0.2 right here minus 0.21 comes from the return of stock 1 in the recessionary state minus the expected return of stock 1. So the same logic we applied to the variance of when we calculate the variance of stock 1, and the same thing for stock 2, the negative 0.1, which is the return of stock 2 in the recessionary state, minus the expected return of stock 2, which is 0.16. And we're going to do that for each state of the economy. So we're going to add that. Once we multiply that out, we'll add that to 0.2, which is the probability of a normal state occurring, times the return of stock 1 minus the expected return, so 0.1 minus 0.21, then the return of stock 2 minus the expected return of stock 2, which is 0.2 minus 0.16, and so on. And when you do that for the expansion state, you get this as well. And when you calculate all that out, you'll get a covariance between stocks 1 and 2 of 0.0514. Now we can calculate the correlation between these two stocks. So how we're going to do that is we're going to take the covariance in the numerator here, that 0.0514, and we're going to divide it by the denominator, which is just the two standard deviations multiplied by each other. So 0.308 times the 0.174. And when you do that, we're going to solve for that and get a positive correlation of 0.959. Remember that correlation is bound between -1 and +1. If correlation is perfectly positively correlated, it is equal to +1, and the two assets will move in the same direction. So when stock 1 goes up, stock 2 will go up. When stock 1 goes down, stock 2 will go down. If it was -1, they are perfectly negatively correlated, and when stock 1 goes up, stock 2 will go down. We're close to that perfectly positive correlation case where it is equal to +1. We're not quite there, but this is a very strong positive correlation. So when stock 1 goes up, stock 2 is going to tend to go up, and vice versa.